All right. Excuse me. Let's go ahead and do 1.5. Let me confess that I already recorded these and something happened when I was uploading them and they wouldn't accept it. So I'm going to have to record this again. So I'm going to use part of the handouts that I did before. And we had gone over a lot of this in class anyway. Okay. Once you get the big picture of the idea and that and the details will help you understand the problem. So now once we know what we're looking for, we can actually start devising a plan to solve the problem. So we're going to talk about some different ways of doing it. We're going to talk about listing, solving similar problems, drawing pictures, using order of operations, providing counterexamples, guess and check, and the multiplication principle. So those are some of the things that we're going to deal with. All right, so we're going to start out with listing strategies. We want to be systematic about things, and so make sure we include every outcome. It's really easy if we don't have a systematic way of doing something to miss a potential outcome. So we talked about something that you've probably used before, which is a tree branch. And we're going to use that in terms of tossing two coins. Now, I'm sure we've all tossed coins before, maybe to settle an argument or just to kill time or whatever. And so we are going to do the first coin. And when you flip two coins, on the first one, the only possibilities are heads or tails. So now we want to look at what the total outcomes are going to be if we flip another coin. So if we start out with heads on the first one, on the second coin we can either have heads or tails, which would lead to a possible outcome of heads, 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 tails. Then we look to the first coin where we did tossed a tail, and the second coin we have the choice of heads or tails. So we can either have tails, heads, or tail, tail. So that gives us four possible outcomes: HH, HT, TH, or TT. Okay, so branching this and doing an organization like this, we can do something that is a much larger problem. So the big question is, how many heads or tail combinations are there possible when you flip 10 coins? Well, there are a couple of ways that we can do this, but that would mean, if you look at the example above, that would mean for this possibility, then we've got to do another one, and then for each of those do another one, and for each of those do another one, and so on and so forth. So that's a big problem. So maybe if we break it down into something simpler, then we can turn around and solve the larger problem without much strain. Okay. So we're going to look at an earlier version of this. We're going to look at something we've already done. If we flip one coin, we can either get a heads or a tails. If we flip two coins, we did that above, we can either get heads, heads, head, tails, tails, heads, or tail, tail. Well, now we want to know how many possible combinations there are if we flip three coins. We're going to talk about two different ways to do this. The first one being, if I can find it now, we are going to look at our three-coin problem, and I'm going to do this where I have some space here. We're going to start out with, if I have three coins, the first method is going to be a tree diagram. We did the tree diagram before, and we're going to start out with our heads and our tails, and notice I'm giving myself a whole lot more space. We know this is the first coin. Now if we do the second coin, we know that for each of these we either have a head or a tail, a head or a tail, which gives us our four possible combinations from the front. Now we're going to add a third one. So if I did a head and a head for each of these, I'm going to have two possibilities: a head or a tail, a head or a tail, a head or a tail, and a head or a tail. Doing it this way, I end up with 8 combinations. If I just follow each branch of this. So I can start here and go head, 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 tail, head, tail, head, and head, tail, tail. Then I look down here, I'm going to do exactly the same thing. I'm going to follow each of the branches. So I'm going to do tail, head, head, tail, head, tail, 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 head, and finally tail, tail, tail. All right. Then there is a second method that we can use, and there are a lot of different ways to do this. I'm going to show you the way I would do it, and that would be creating a systematic list. And there are a lot of different ways to do this, but the way I organize it, I said, all right, well, how many, if there are 3 coins, what are the possibility if there are 3 heads? What are the possibilities if there are 2 heads? What are the possibility if there is 1 head? And what if there's no head? Whoops, sorry about that. Well, there's only one possibility when they're all heads. Head, head, head. Now 2 heads, I've got head, head, tail, head, tail, head, tail, head, head, and that's all of those. Then if there's 1 head, I've got head, tail, 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 head, tail, and finally tail, tail, head. And then lastly, there is 1 possibility which has 0 heads. Now obviously you could have done the same thing with if you had listed it with how many tails or some other fashion. Okay, now we did this in class as well, and I think all of you kind of figured this out. When you are looking at this, for if you have 1 coin, there are 2 possible outcomes. 2 coins, there are 4. 3 coins, that are 8. And then we tell you that if you have 6 coins, there are 64 possibilities. Well, what's going on between these numbers, and how would I get from 6 to 64? Well, what I'm doing each time is multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 gives me 64. Now, a shortcut for repeated multiplication is exponents. So the pattern is taking 2 and multiplying itself n times. So if I'm multiplying it, 2 to the first gives me 2. 2 to the second is 2 times 2, or 4. 2 to the third is 2 times 2 times 2. 2 to the fourth is 16. 2 to the fifth means 2 times itself 5 times. 2 to the sixth is 64. All right, well, this leads us into the multiplication, and we're going to use this by doing a problem with the number of outfits you can create. You've got 3 styles of polo shirts. They're your employer uniforms, and either khaki or black pants. So you have all 3 styles of polo shirts and 2 different kinds of pants. How many work outfit combinations do you own? Well, if we look at the tree method, here I am ready to get dressed for work. I've got polo 1, polo 2, polo 3. And if I pick this shirt, then I have either the khaki or the black pants. If I pick this shirt, I have the khaki or the black pants. And if I pick this shirt, I have the khaki or the black pants. So I end up with 6 combinations. Now what's cool about this is we can boil it down to the multiplication principle. What it states, if there are a way of doing one thing and B ways to do a second thing, then you just multiply them. So if there are 3 ways to do shirts and 2 ways to do pants, 3 times 2 gives you 6 combinations. If you have 3 shirts, 2 pants, and 4 shoes, it would be 3 times 2 times 4, which would give you 24 possible outfits, and so on and so forth. So these answers match, and they always will. Now, you can also go back and apply this if you do a total number when you have 3 coins. You have 2 choices for number 1, heads or tails. Heads or tails for the second, heads or tails for the third. 2 times 2 times 2 gives you 8, which is also the same as 2 to the third. Okay, going to stop here and then we will do guess and check.